Today our lesson is called compound events. Does anyone think you might know what compound events means?
Is it multiple events?
Multiple events, very good, okay? It's not just one event. We've talked about probability with one event. Today we're going to talk about it with compound events. As he said, more than one event. The first vocab word that I want to have today for you to understand is sample space. So go ahead and write this into your notes. The sample space is the set of all possible outcomes of one or more events. So really what the sample space is, it's simply a space, or it allows us to have a space where we can show how we found the possible outcomes of our thing that we're trying to find. First thing we're going to talk about today is how to find the sample space by using a tree diagram. Okay, so how many of you have a favorite sandwich shop, a place that you like to go? Where do you go?
Dailies.
Okay, Dailies. Who else? Firehouse Subs. What else?
Subway.
Subway. Sam's. Okay, very nice. So there's a lot of places that sell subs. The first thing they normally say to you is, what kind of what do you want? Bread. What kind of bread do you want it on, okay? So what we're doing today is we're going to randomly choose a bread and a type of sandwich. You can see there's 4 different types here. You could get ham, turkey, steak, or chicken. And you're trying to find the sample space. And while doing that, we're going to see how many different sandwiches are possible. So when you do something called a tree diagram, you always want to start with the thing that has the smallest amount of options. Which one up there has the smallest amount of options? The bread. So let's go ahead over here on the left-hand side. I want you to write the word bread. And there's 2 kinds of bread. What are they?
Wheat and sourdough.
Wheat and sourdough. So give yourself a little bit of space. The first one is wheat. The second one is sourdough. How many of you have ever had sourdough before?
Is it sour?
It's not my favorite. It is a little more sour than white bread. Or it's not actually sour though. It's just kind of, yeah. So of the 2 options, how many of you would rather have wheat bread? Who would rather have the sourdough bread? All right. Hands are down. Next up, we have 2 kinds of bread, and we have 4 types of sandwiches. So over here, we're going to go ahead and write down what the types are. Guys, what are the 4 types? All right, so let's write that down. Okay, so with these different options, I could get wheat, I could put ham on my wheat, or I could get turkey on my wheat, or steak, or chicken, okay? Now, down in my sourdough, what types could I have with the sourdough bread?
All of them.
The same exact kinds also, so go ahead and write them down again. So just like we did before, now I have the sourdough option of having ham or turkey, steak, or chicken. So let's think about what the outcomes are now that we've talked about this. So our final column for our tree diagram are the outcomes. So for the sake of time, I'm going to just write it like this. I could have wheat, W stands for wheat, ham on my wheat, or I could have turkey on my wheat, steak, or chicken. And I could do the same exact thing with my sourdough bread. I'm just going to write SD for making it a little faster. So we've got sourdough with ham, sourdough with turkey, sourdough with steak, and sourdough with chicken. So looking at all of my outcomes right here. Guys, how many different options were there?
4.
There's 4 right here, but there's also 4 different ones right there. So how many total? 8 total. It's asking you how many sandwich options there are. We're going to say 8 sandwich options. Doing things with the tree diagram takes us a long time, especially if there are multiple options. So instead, there's something that I want to teach you called the fundamental counting principle. So this is asking us to use the fundamental counting principle to find the total number of possible outcomes. The fundamental counting principle is where you simply multiply the possible outcomes from each category together to find the total number of possible outcomes. Now, as we talked about before, this is a compound event, which means it's more than one event. Here it asks me to find the total number of possible outcomes of rolling a number cube. So everybody go ahead and underline rolling a number cube. And what's the other thing that we're trying to figure out? Flipping a coin. So the first thing we want to do here is see how many options are there on a number cube? 6. Okay, there are 6 different numbers on a number cube, so let's write that down. How many different options are there when you flip a coin? 2. So the fundamental counting principle says all you have to do is multiply those 2 together. What's 6 times 2? 12. And here the answer is 12 possible what? Outcomes. Whenever you have problems like this, you want to make sure that you are putting units attached. Okay, so thinking about our sandwich option problem that we had before, how many kinds of bread were there? 2. How many types of meat were there? 4. What's 2 times 4? 8. So we did a huge tree diagram, but the fundamental counting principle tells me I could have just done 2 times 4 and not done all that work. Okay, so what would you rather do? Fundamental counting principle or the tree diagram? All right, then let's continue and we will just use the fundamental counting principle instead. Here I have a picture for you. It says to find the total number of possible outcomes. First up, how many different outfits can you make from this wardrobe closet? So let's start up here. How many pairs of pants do you see there?
4.
There are 4 kinds of pants. And I'm going to multiply it times. How many kinds of shirts do you see hanging up there?
7.
There are 7 different shirts. Now there's one more thing in there. What is still in there? How many pairs of shoes are there? There are 3. So if you remember, the commutative property tells us that I can multiply these numbers out of order. So let's not use calculators right now. Use your brain. Let's just do, what is 4 times 3? 12. And then what is 12 times 7?
84.
84. So what's the answer, guys?
84 possible outcomes.
Okay. So you could say 84 possible outcomes, or you could say 84 possible outfits. Okay. I don't care which one. If you want to make it specific, or if you just want to say possible outcomes, that's totally fine. I want you and your partner to do problem B together. So the next one, what'd you guys get?
100 possible outcomes.
Okay, very good. So for showing the work, you're just going to do 4 times 5 times 5. And the correct answer is 100 possible outfits or outcomes. Either one is fine. Okay, let's do another example. Find the probability of the compound event. So go ahead and turn the page. I want you to take your red pen and just go ahead and highlight these 2 words, compound event. When you see that, how many events are we looking for? 1 or more than 1? Multiple. So it's going to be more than 1 event. So let's talk now about theoretical probability. For your quiz on Monday, you're going to have to know the definition or the formula for theoretical probability? What would that be, guys?
Success is over trial.
No.
Favorable
That's
outcome.
favorable over favorable.
Everybody write this down. Favorable over total. Now remember, favorable simply means how many times did you get what you were looking for? Okay, that's favorable if you get what you were looking for. So there's compound event happening here. I want you guys to underline this first part for me. Rolling a number greater than 4. All right, so let's just think about rolling a number greater than 4. How many numbers greater than 4 are on a number cube?
2.
2. What numbers are those?
5 and 6.
5 and 6. So favorable, things we're looking for, there's only 2 options on that number cube that are greater than 4. How many total numbers are on my number cube?
6.
Okay, so I have a 2 out of 6 chance that I'm going to roll a number greater than 4. But it's a compound event, all right? So I also have to see, what is the probability of me flipping tails? How many tails are there on a coin?
1.
There's only 1. And how many total sides are there?
2.
2. The fundamental counting principle told me I have to take those 2 events and do what to them? Multiply them together. Now, if you remember when multiplying fractions, multiply it across, guys. What's 2 times 1? 2. And then multiply the denominator. What's 6 times 2?
12.
Can that be reduced? To what?
1/6.
1/6. Now, for probability, I want to know, for this one, let's go ahead and round it to the nearest whole percent. So go ahead and write down what the nearest whole percent would be. When you do 1 divided by 6, what do you get? Okay, we've got it repeating there. So now, this would equal 16.6% repeating. But we want to round that to the nearest whole number, okay? So remember, take this and see if that number is going to bump it up or not. Does it bump it up?
Yes.
Yes, so what's the answer?
17%.
17%. If I want it rounded to the nearest whole number, there's a 17% chance that I am going to roll a number greater than 4 and flip tails. Guys, if I were to ask you what the likelihood is, remember those words? Is this very likely to happen? It's unlikely. That's probably not going to happen very often. All right, I want you and your partner to do problem B together. All right, guys, let's see what you came up with. Once again, we are using the favorable over total formula. Compound event. First thing I want to do is roll at most a 4. Is the number 4 an option?
No.
Yes, at most it could be a 4. It could be what other numbers? 3, 2, or 1. So how many numbers, if I'm looking to roll at most, that means I don't want anything bigger than 4. How many options are there on my cube? 4 out of how many? 4 out of 6 total numbers. I want to flip heads. What's the probability I'm going to flip heads? A 1 out of 2 chance. So you simply multiply across, you get 1/3, which is, okay, it goes on and on and on forever, but I want to round to the nearest whole number, and I get what? 33%. So the difference between this one is we're spinning a spinner instead of using a cube, okay? So what is the probability of spinning an odd number and flipping tails? How many odd numbers are here on my spinner?
4.
Okay, so starting with this right here, we've got favorable over total. There are a total of 4 odd numbers out of how many? 8. So I have a 4 out of 8 chance of spinning an odd number. What are my odds or my probability of flipping tails?
1/2.
A 1 out of 2 chance. Okay, what do I do to those 2? Multiply it. So then what do I get when I multiply? 4/16, which reduces down to
1/2.
1/4. And then what's my percentage?
25%.
25%. 1/4 is 25%.